Welcome to Etabs, an extremely versatile and powerful object-based program with many features and functions for the analysis and design of buildings. Etabs is a standalone finite element program that works off an integrated database so that you need only create one model consisting of the floor system and the vertical and lateral framing systems to analyze and design the entire building. All options are accessed through one interface, and there are no external modules to maintain or transfer data to. This tutorial will illustrate the fundamentals of working with Etabs, and will show how quickly and easily a model can be created. At the completion of the tutorial, the building shown will have been created, analyzed, and designed. Our project will be a 4-story building where the first story is 15 feet, and the remaining stories are each 12 feet high. The bays are all 24 feet by 24 feet, and the lateral system will be steel moment frames. No beam may exceed a depth of a W18. We start by setting the building grid and story dimensions. Check the box in the lower right corner to make sure that the units are correct, in our case cubic inches. Click the File menu New Model command, and on the New Model form select No, as our model will be completely new. The building plan grid system and story data form is used to specify our grid line and story data. Set the number of stories equal to 4, and type 15 feet for the bottom height. The program will automatically convert to inch units. Select Grid Only, and click OK. Our building grid is complete. Next, we will define an auto-select section list, which is simply a list of sections that may be assigned to frame members. When an auto-select section list is assigned to a frame member, the program can automatically select the most economical, adequate section. Because we are restricted to a maximum beam depth of 18 inches, we will create an auto-select section list that contains W16 and W18 beams. Click the Define menu Frame Sections command, and on this form, click the drop-down box that says Add Auto-Select List. Type AutoLat Beam for the list name, and scroll down on the list of beam sections until you find W16 by 26. Click once on this beam, and holding the Shift key down, scroll down further until you find W18 by 175. Click the Add button, and note that the program will use the median section as the starting section. Now we will add line objects to multiple stories. These line objects will represent our columns and beams. First, make sure that the plan view is active. You may do this by clicking anywhere in the window. Next, click the drop-down box in the lower right corner that reads one story and select Similar Stories. To review these definitions, click the Edit menu, Edit Story Data, Edit Story command. By default, the program has defined Story 4 as the master story, and Stories 1, 2, and 3 as similar to 4. This means that any drawing or selection performed on one story will apply to all of the other similar stories. Next, draw column objects by clicking on the Create Columns in Region or at Clicks button. Make sure that the property item is set to ALAT Call, which is a built-in auto-select sections list used for lateral force-resisting columns. Click in the Angle Edit box and set the angle to 90 degrees to rotate the columns 90 degrees from the default settings. To draw the first column, left-click at the intersection of grids D1. We will add another column at D2, and note that the columns are displayed over all 4 stories because of similar stories being active. Now change the angle from 90 to 0 and draw the remaining columns in one action by windowing using a selection box. Click the Select Object button, and holding the Control key down, click in the plan view on column A2. Select the column in the list, and note that the status bar in the lower left corner indicates 4 lines have been selected. Repeat the process at B2, A3, C3, and C4. The status bar should show 20 lines selected. Click the Assign menu, Frame Line Local Axes command, and select the Major Direction is Y option. The selected columns rotate 90 degrees. Notice that the local axes of the columns are displayed. These axes may be shut off by clicking on the Assign menu, Clear Display of Assigns. During development, make sure to save the model often by using the File menu Save command. Next, we will draw the lateral force resisting beam objects. First, make sure that the plan view is active, and then click the Create Lines and Regions or Eclipse button. Click on the Property Edit box and scroll down to select Auto Lat Beam, the Auto Select Sections list we created and named previously. Left-click once on grid line D between 1 and 2. Note that the beams are created at all levels due to similar stories being active. Draw beams on grid lines 1 and 2 in a similar manner. Now draw the remaining beams in one action by windowing around the grid lines using the selection box technique. Click the Select Object button and left-click once on the beam located on grid line C. This selects the beams at this location for deletion. Now we will draw the secondary infill beam objects. Once again, make sure that the plan view is active and click on the Create Secondary Beams in Region or Eclipse button. Make sure that the property item is set to A Comp Beam, an auto selection list for composite secondary beams. Left-click in the bay bounded by C, D, 1, and 2 to draw the beams. Draw the remaining infill beams by windowing around the other bays. Next, go to the Select menu, Intersecting Line command. Left-click the mouse next to the beams to be selected, and while holding the button down, drag across the beams. The selected beams may now be deleted. In this step, floors will be added to the building by drawing floor area objects. Again, make sure that the plan view is selected and click the Draw Areas button, and check to make sure that the property selection is Deck 1. Also check that the Snap to Grid Intersections and Points command is active. Click once at column A1 and every other corner as you move clockwise around the model to draw the outline of the building. Press the Enter key after clicking on D1. Note the two-headed arrow indicates the direction of the deck span. Click the Select Object button and go to the View menu, set Building View Options command. Make sure that the Object Fill effect is selected and apply to all windows. Next, click the Define menu, Wall Slab Deck Sections, and select Deck 1. We will modify the slab depth to 3 inches. Now we will add some dummy area objects that have no mass or stiffness to the model to be used for the application of a wind load. We will add the first of these objects in an elevation view. Select the 3D view as active and click on the elevation view button. Select grid line A and click OK. Click the Create Areas at Click button and select None from the drop-down Property Edit box. Click once in each of the bays to add the dummy area objects. Change the elevation view back to a plan view and select Story 4. Click the Create Walls in Region or Click button and click on grid lines C, B, and D to add dummy walls in these bays at all levels due to the Similar Stories feature. Click the Select Object button to return the program to the Select mode, and change the right window back to a 3D view. In this portion of the tutorial, we will apply vertical and lateral static loads to our model, consisting of dead, live, earthquake, and wind. The loads to be applied are as shown. The program will automatically calculate the IBC earthquake load and the ASCE wind load. Start by clicking on the Define Static Load Cases button. Note that there are two default load cases, dead and live. Click on Live and select Reduce Live from the Type drop-down list. Click the Modify Load button to change to a reducible live load. Click in the load box and type a new name, SDead, for Superimposed Dead Load, and select SuperDead for type. Click the Add New Load button. Repeat this action for a load named Cladding. To define the IBC 2003 earthquake load, click in the load box and type EQY, and select Quake for load type. Make sure that the self-weight is set to 0, and from the lateral load pull-down, select IBC 2003 and click the Add New Load button. With EQY highlighted, select the Modify Lateral Load button, and on this form, click the Y direction. To define the ASCE 702 wind load, click in the load box and type WindX, and select Wind for the load type. Click ASCE 702 from the lateral load menu, and press Add New Load. With WindX highlighted, click the Modify Lateral Load button, and select the exposure from Frame and Area Objects option. And type 100 into the wind speed box, and then click OK. Next, we will assign the gravity loads to the model. Make sure that the plan view is active and that the Similar Stories is selected. Click anywhere on the deck in between beams to select the deck. Click the Assign Shell Area Loads Uniform command, and select SDead on this form. Hold down the Shift key and double-click in the load field to bring up the calculator form. Make sure that pound-feet is selected and type in 35. The program will automatically convert to kip inch units. Again, click anywhere on the deck but not on a beam, and select the Assign Shell Area Loads Uniform command. Select Live and enter 100 in pound-feet units. Next, set the Snap to Grid option to Off, and select the perimeter beam along grid line A between 1 and 2. Note that 4 lines have been selected due to the Similar Stories option. Select the other 13 perimeter beams in a similar manner. Once all the perimeter beams have been selected, click on Assign Frame Line Loads Distributed, and choose Cladding from the load cases. Using pound-foot units, assign a value of 250 to the Uniform Load option. Make sure that the plan view is active and click on the 3D view button to display the loads that were just applied. Click the Assign menu, Clear Display to remove this display, and then return the view to a plan using the Plan View button. Now we will create a developed elevation view of the right side of the building so that a wind load may be applied to it at a later time. Start by clicking on the Draw menu, Draw Developed Elevation Definition command. Type right in the edit box for our elevation name and click Add New Name. Turn the Snap to Grid Intersections command on, and working in the left-hand view, click once at grid D1. Then moving counterclockwise, click at D2, B2, B3, C3, and C4 in that order. When all the points have been clicked, press Enter to finish the drawing and press the Escape key to exit the draw mode. Next, click the Elevation View button and select Right and click OK. The developed elevation is an unfolded view of our right elevation. It is indicated on the 3D plan by the cyan colored lines. Now return the elevation view back to a plan view by clicking on the Plan View button. Next, we will assign wind loads to two sides of the building, utilizing the developed elevation just created. Typically, positive wind pressure coefficients are applied to the vertical surface of an area object, generating load in the positive local 3-axis direction. Set the 3D view as active, and click on the View menu, Set Building View Options command. Set the Area Local Axes option to On. Note that the 3 or blue axes for the dummy area objects point in the positive X direction. Click the Rotate 3D View button and spin them all around to see the other side of the building. Confirm that the 3 axes on this side are also in the positive X direction. Through the Set Building View Options command, uncheck the Area Local Axes and click OK. With the 3D view active, click on the Elevation View button and select A. Draw a selection box around the entire elevation to select all of the area objects, and then click the Assign menu, Shell Area Loads, Wind Pressure Coefficient command. Make sure that the load case is Windex and that C sub P is set to 0.8 and that the windward option is checked. With the Elevation View active, click on the Elevation View button once again and select Right. Draw a selection box around the entire elevation once again and pull up the wind pressure coefficient form. This time set C sub P equal to 0.5 and check the leeward or sides option. Click on the Clear Display of Assigns and return the view to a 3D view. Now that all the loads have been assigned, we will do a quick review of the wind pressure coefficients utilizing the Database Display option. Click the Display menu, Show Tables command to bring up the database tables. Click on the Area Assignments box and then check OK. Go to the drop-down list and select Area Wind Pressures. Each row in the corresponding table represents one area object. Note that the fifth column displays the C sub P coefficients that were previously input for the vertical area objects. The next three columns display the X, Y, and Z components. Notice that all the load is in the positive global X direction as desired. Now we are ready to analyze the object-based ETABS model, which we can do by clicking on the Run Analysis button or through the Analyze menu Run Analysis command. A window will open displaying Analyzing, Please Wait, and data will roll across the screen as the program executes each portion of the analysis. When the process is complete, the program automatically displays a deformed shape of the model, and the model is locked, preventing any changes that would invalidate the analysis results. Next, we will graphically review our analysis results. Make sure that the 3D view is active and click on the Elevation button and select one. Click the Display menu, Show Member Force, frame forces command to generate member force diagrams. Select dead static load and moment 3-3. On the member force display, right-click on a beam to bring up the individual diagrams. Note that the applied load, shear, moment, and deflection are shown. Click the Scroll for Values option, and you may scroll along the member to any location. Change the units to kip feet, and enter 6.5 in the location box, and the corresponding values are displayed. We will reset the view by clicking on the display menu Show Undeformed Shape command. Now that the analysis is complete, we can start the design process. In the plan view, right-click on one of the secondary beams. Note that the program has assigned composite beam as the design procedure. Due to the fact that the beam lies in a horizontal plane, the ends are pinned and it is an I-shaped steel section. Review the information on the other tabs and then click OK. Click the Options menu, Preferences, Composite Beam Design command, and make sure that the design code selected is AISC LRFD 99. Review the information on the other tabs and click OK. Set the 3D view to active and click on the Set Building View Options button. On the form, uncheck the All Null Areas box as well as the Object Fill box and apply to all windows. To start the design process, select Design menu, Composite Beam Design, Start Design without similarity. The program will design the composite beams, selecting the optimum size for each from the AComp Beam Auto Select section list. When the design is complete, the selected sizes are displayed on the model. Click the Design menu, Composite Beam Design, Verify Analysis versus Design section command. The message displayed indicates that the members selected in the design phase differ from those used in the initial analysis. Our goal is to repeat the analysis and design procedures until the members in both are the same. Select No to continue our iteration. Right-click on one of the composite beams in the 3D view, and you will see that the analysis and design sections are not the same. The acceptable sections list shows all the members that are adequate for the design criteria. Click on the Details button, and the form displays all of the design information about the beam. Review the information on the other tabs, and click on the X to close the form. To rerun the analysis, using the members just selected in design, click the Run Analysis button. Again, choose the Design menu, Composite Beam Design, Start Design without similarity. Once the members have been designed, click the Design menu, Composite Beam Design, Verify Analysis versus Design section command. All analysis and design sections now match. As a final check, select the Design menu, Composite Beam Design, Verify All Members Passed command, which shows that all members have passed the design check. Click the Select All button to select all the objects in the model. Next, select the Design menu, Composite Beam Design, make Auto Select Section Null command, and click OK to remove the Auto Select Section List assignments and replace them with the current design sections. Next, click the Clear Selection command. Next, we will design the steel frame portion of our building. First, check under the Options Preferences command that for steel frame design, we are using the AISC ASD 01 code. Next, make the plan view active and right-click on a lateral force-resisting beam on one of the grid lines. Review the information and note that the design procedure is steel frame. Change the 3D view to active and start the design by selecting the Design menu, Steel Frame Design, Start Design Check of Structure command. The initial design is complete, and this form indicates that the design sections chosen differ from those of the initial analysis, which were simply the median weight sections from the auto-select list. Change back to the plan view and click on the Design menu, Steel Frame Design, Display Design Info. And make sure that the PM ratio is selected. The member design results are now displayed in the plan view. In the plan view, right-click on a primary beam to bring up the Steel Stress Check form. Note that the analysis and design sections are different. Also note that the program automatically generated code-specific design load combinations. Click on the Details button to bring up a detailed calculation sheet for this beam, which can be printed out. Close these forms and select the Design menu, Steel Frame Design, Select Design Combo command to review the load combinations. Highlight one design combo, and then click Show to see the cases that make up this combination. Return to the Design menu, Design Steel Frame, Verify Analysis versus Design Section command. As the design and analysis sections are different, we will need to rerun the analysis using the current design sections. Upon completion of the analysis, rerun the design and then verify that the analysis and design sections match. If they do not, perform the cycle once more. This concludes this tutorial.